typing the notes I had typed up, and I'm redoing it here, so I'm just going to write it. Okay, so I've tried to kind of organize this into a couple different types of problems, and maybe this reorganizing might help make it a little bit easier for you when you sit down to do it on your own. So we just got done with the rational exponents. And I could ask you, we can go back and forth between the two. If I said to write x to the 3/5, in radical form. So x to the 3/5, that was like how you would have seen that in the last section. If I want to write it with a radical, like we would see it in this section, which number goes outside? The 5. Now, that's just the index on the radical. I don't want to see this because that means something different. This means 5 times the radical. I want the 5th root. So that's just a small 5 up in the corner. And then it's x to the 3rd. And it doesn't matter if you put that 3rd under the radical or not. Both ways are correct. So either way you wrote it would be fine. Okay, if we went the other way. If I said to write, let's do the 7th root of y to the 10th in exponential form. Okay, so we can see it with a radical, or we can see it with an exponent. This would be y to what power? That index on the radical is your denominator every time. If you have a radical with no index, what do we assume it is? I gave you this. That would be x to the 5/2, right? If there's no number, it's assumed to be a 2. So you can write it in. If it helps you, you can leave it off. It's not going to matter. All right, so we can go back and forth between the notations. What I want to talk about now is reducing radicals. So you did do this in Algebra 2. Let's see how much of that we remember. So that's going to be the first type we do. If you are working inside this first, what is a -7 squared? Positive 49, -7 times -7. What is the square root of positive 49? So this one just turns into a 7. Okay, it's very tempting at the beginning to just say, oh, the square root and the square are going to cancel out, so I get a -7. The reason that isn't correct is the definition of the square root is to give me the positive root. So when you have a square root, it'll always be a positive number coming out. Easier way to see that is if we actually work it out. Now I know in Algebra 2, I don't know if you remember this, sometimes your variables could be positive, sometimes they could be negative, sometimes you have to throw absolute values on your answers. We're not going to worry about anything quite that complex. We're just going to, if you're paying attention all the directions, we'll always say, assume all the variables are positive. So you won't have to worry about, could this be a negative or not. We're just going to deal with positives. All right. If I said you have the cube root of 64, a to the 6th, and b to the 15th. long as all this stuff is multiplied together, so as long as it's at one term, we can go through and reduce. So if I have the cube root of 64, that's like saying what number to the third power equals 64? You can use your calculator. Do you guys remember how to do that if you got a big number? You can do any root you want. So like a cube root, if you hit 3 for the cube, then go math, and then it's number 5. You can do any kind of root that you want on there. All right, a to the 6th. So let's talk about this. That's like saying I have 6 8s. This cube root tells me I can pull them out in groups of 3. So if I have 6 of them. How many groups of 3 does that form? 2. Okay, if I have 15 b's, to find how many groups of 3, we get 5. Now another way to think about that. If you wrote this in rational form, that's a to the 6 over 3 power, and 6 divided by 3 is 2. With your b's, that's like b to the 15 divided by 3. 15 divided by 3 is 5. So different ways to think about it, whatever makes the most sense to you. I said the 4th root of 32. So try your calculator. What does it give you?
2.4.
All right. I'm going to tell you that I don't want decimals. I want these in radical form. So just like we've broken down square roots, we can break down 4th roots. So if we think about this, I need something to the 4th power that goes into 32 equally. So when I say something to the 4th, like 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256. Is 32 divisible by any of those numbers? 16. So you don't necessarily have to write this, but this is what I'm thinking in my head. I'm breaking that 32 down into a 16 and a 2. But the 4th root of 16, that does come out evenly, and that is 2. And then I can't break down the 4th root of 2, so that just stays. You do have to keep that 4 for the 4th root. You can't drop that. Make sure it is that small 4 up there so it doesn't look like 24 times the square root or anything like that. Do you guys remember doing some of this last year?
Yeah.
Okay, good. Let's do the cube root of b squared over c to the 9. When you have these radicals, if you have things multiplied, you can do each one separately. The same is true for the division. So we're really just going to do the top and the bottom. Okay? On the top, it's a cube root, so I need 3 of them before I can pull it out. If I have a b squared, do I have enough to make a group of 3? No, so it just stays under my cube root. Okay, let's look at the bottom. I have 9 c's. How many groups of 3 can you form? 3. 9 divided by 3 is 3. So since you pull that out, that radical disappears. So it's just the cube root of b squared over c to the 3rd. The cube root is only left on the top because the bottom we were able to pull everything out. let's do a negative square root 18 x to the 5th y to the 7th. Okay. Does that negative on the outside change anything? No, it's just going to carry over in my answer. So if you start with a negative on the outside, you've got a negative on your answer. Okay, 18, is that a perfect square? You can do the square root of 18? No. Because it's a square root, I need to break it up into something that I can do the square root of. So that would be 9 and 2. Square root of 9 is, so a 3 comes out, and we cannot do the square root of 2, so it stays under the radical. X to the 5th. So remember, it's like an imaginary 2 out here. If you have 5 x's, how many groups of 2 can we form? 2 complete groups, so that means x squared comes out. Do we have any left over? No. 1 left over, so 1x stays underneath. My y's. If I have 7 y's, how many groups of 2 can you form? 3. So a y to the 3rd comes out. Are there any y's left over? We have 1 y left over. So if you don't have enough to make an even group, it just stays under our radical. We have the 4th root of a to the 7, b to the 10 over c to the 8. So if things are multiplied or divided, I can do every radical individually. Okay. If you have 7 8's, it is a 4th root. How many groups of 4 can you form? 1 comes out. Do we have leftovers? 3 more. So under my 4th root, we still have an a to the 3rd. Okay, my b's. If I have 10 b's, how many groups of 4 can I form? 2. So b squared comes out. That would account for 8 of them, so we have 2 left. On the bottom, we have c to the 8th. So if you have 8 c's, how many groups of 2? Or sorry, how many groups of 4? 2. So there's 2 that come out. Are there any left over?
No.
So that radical's gone. Okay. Do you guys need a few to try on your own? Okay, I'm going to put a few up here, and I would like for everybody to try these. So I want you to do,
Reese, can you get my pencil, please? Reese, pick up my pencil. Hey, Reese.
Not no problem, just pick up the pen.
So you have to pay attention. And the first one, I noticed a couple of you started out by doing squares. It is a third root. So we are thinking about things to the third power that go into 24. So I kind of made a list up here on the board. We need a perfect cube. So those are like my 8, 27, 64 that would divide 24 evenly. So what works? 8. So we could think of that as an 8 and a 3. Now, what is the cube root of 8?
2.
So a 2 comes out. This 3 is still left underneath, and it's still my cube root. Okay, if I have 5 A's, how many groups of 3 can you form? That would take 3 of them, so there are 2 left. All right, if I have 10 B's, how many groups of 3 can you form? And how many are left? All right. Questions on that one? Please ask if you do have a question. Okay, so B. It's a fourth root, so I'm looking at my list of things to the fourth power that divide 48 evenly. So that's my 16, 81, 256, so on. Which of those divides 48 evenly? 16. So I'm thinking of that 48 as a 16 times 3. So the fourth root of 16 is 2. So a 2 comes out. We can't break down that 3, so it stays underneath. We have 9 x's. How many groups of 4 can you form? 2. So an x squared comes out. Then how many were left over? So 1 stays underneath. On the bottom, if you have 12 y's, how many groups of 4 can we form? 3. So a y cubed stays on the bottom. All right, C, it's a square root. So 50, what could we break it into? We need a perfect square.
Square root of 25 and 2.
So the square root of 25 is 5, so a 5 comes out, 2 stays underneath. I only have 1a. That's not enough to form a group of 2, so it's just going to stay. If I have 5 b's, how many groups of 2?
2.
So b squared comes out, and there was
1 b left.
1 b left. On the bottom, what's the square root of 9?
3.
And if you have 20 c's, how many groups of 2?
10.
So once you break it up, that radical disappears on the bottom because all of those were perfect squares. How are we doing on that? I want to look at just a few more examples. So kind of dealing with some properties of radicals, but we'll still be breaking apart these radicals as we go. So we'll keep practicing this part. If I gave you let's say the square root of the cube root of 27. Where do you start on a problem like this? The outside or the inside? Inside. Can you do the cube root of 27? And it is 3. So that cube root of 27 I simplified into a 3. We haven't done that square root yet, so it stays. Can I break apart the square root of 3? No, so that's my final answer. Okay, so if you have multiple radicals, just start on the inside and work your way out. If I gave you, let's say, the square root of 6a times the square root of 7ab. If I'm asking you to multiply radicals, you can do that. You can multiply any radicals together. When you do that, the radical stays, and you just multiply the numbers underneath. So 6 times 7 A times A, and then we just have that B. Okay, so then we have to make sure we can't break it down. 42, let's see, can I divide it by any of my perfect squares? 4, 9, 16, 25, 36, no. So if it's not divisible by a perfect square, we just keep it. If I have an A squared, what would I do? Yeah, this is a square root, so we can pull out groups of 2. So if you have 2 A's, one of them can come out. And I only have one B, so I can't simplify that. So it's just A times the square root of 42B. So if they're multiplied, just multiply things underneath together. We'll see more problems like this tomorrow, but I might ask you to do a problem like this. So a multiplication, but I have 2 parentheses. So what would we have to do there? We have to distribute everything out for you. When you multiply numbers outside the radical together, and you multiply numbers under the radical together. So 3 times 2 is a 6. Square root 5 times 5 is 25. Outside, 3 radical 5 times 1 is just 3 radical 5. Inside, so the 2's are both outside the radicals, so negative 2 times 2 is 4, and the radical 5 stays. And then negative 2 times 1 is negative 2. In order to add or subtract radicals, it has to be the same thing under the radical. They have to be like terms, just like you have to add, like if you want to add x squared, it has to have another x squared term to put it together. What do you notice about 6 square root of 25? Yeah. Square root of 25 is 5, so that's 6 times 5, so that's a 30. These are like terms because they both have a square root of 5. So just like if I said 3x and negative 4x, you put them together and you get negative x. You add numbers in front, the x doesn't change. Same thing here. 3 radical 5 and negative 4 radical 5 would just be negative 1 radical 5. Or just negative radical 5 if you don't want to write the 1. And then minus 2. So like terms 30 and negative 2 is negative 28 minus radical 5. I'll do one last problem for the day. So I'm asking you to add and subtract, but can you add or subtract those radicals? What do you have to do it? What did I just say? Same thing under the radical. So we need to break these apart first and see if we can get it to a point where we can add them together. So 16, it's a cube root. Can I break that up into anything that I could reduce? 8 and 2. The cube root of 8 is 2 times the 5 that's already there, which just means 5 times 2 times the cube root of 2. So I get 10 cube root of 2. And you don't necessarily have to show all this work. I'm just trying to show you exactly what I'm doing here. 54. Look at your cubes. Is it divisible by any of these numbers? 27. Okay, the cube root of 27 is 3. Multiply with the 3 that's already there. 3 times 3 will give me a 9. Cube root of 2. Can I break apart 4 cube root of 2? Is there anything to do there? No. So that just stays. At this point, all 3 of them have a cube root of 2. So all you have to do is add these coefficients. So 10 plus 9 minus 4. So we have 15, and the cube root of 2 just stays for your answer. Any questions there? So I'm not done with this section yet. The assignment, I did a handout instead of Math Excel this time. So there's a handout posted in Classroom. This is the entire assignment for the section. Okay, so you technically know how to do most of it right now. Technically, you could probably do 1 through 19, but you don't have to have that all done. Tomorrow, all we have to talk about is one last part of this, and so I'll spend part of the class talking about those examples, and then part of the class you'll have some time to work. But you should be able to get a good start on this. That way, you can bring any questions that you're having to class tomorrow. Okay, so the handout will be due, let's see, today is Tuesday, so it'll be due Thursday.